Okay, let's get started. Shall we? So today I'm going to go over some Matlab skills for beginners and for those who have known a little bit about Matlab. The name for Matlab is from two words, matrix laboratory. So if you are coding with Matlab, you have to know two major agendas. First of all, Matlab is all about matrix. So you have to have a matrix state of mind enable you to code with it. And the second one is that Matlab is a numerical software. So does anyone know what numerical means? Numerical. In Chinese, it's 数值, right? 数值. So the opposite of numeric is actually analytical. So let's compare analytical solution and numerical solution, all right? I have a quadratic function here, or a quadratic equation. To be more precisely, x squared plus x minus 1 is equal to 0. If you want to solve it analytically, you can simply plug it into the quadratic formula. So an analytical solution is something that has a formula, basically. But if you want to solve it numerically, you can only use graphical solution. So you basically graph this quadratic curve, like this here. And then you just go point by point to that point that it goes through the x-axis. And you go for the x-coordinate of those points. That is called a numerical solution. So essentially, the difference between analytical solution and numerical solution is that in numerical solution, you only get an approximating value, right? So in Matlab, you cannot get something with square root in your solution. You can only get something that have some decimal places. All right, so let's start from the user interface of Matlab. If you launch Matlab, this is the first window you're going to see. We call this the command window, all right? We call this a command window. Inside this window, we have two sections, the left-hand side part and the right-hand side part. The left-hand side section is called command window. Here it is a calculator-like environment, so you can just do some simple calculations here. So let's try this. Please launch your Matlab, all right? Turn on your laptop and launch your Matlab. Let's try to do some examples here. And then you can type in 1 plus 2 plus 3 all the way to 10. After you do so, hit enter, right? Hit enter. And after you hit enter, you should get this line here. ANS equals to 55. So you know Matlab is just a calculator in the most basic aspect of it, right? As soon as you type in this line, you have answer equal to 55. You will see ANS 55 on the right-hand side. That part is called the workspace. It is where your variables are displayed. So you can see all your variables here. And it is quite essential since with all the variable displayed, you can do some debugging at this section. So when you are coding, you want to run the process in your mind, and you will think what the variable should be in this stage. And you can compare that value with the value displayed in this section. If there are some difference, you can go into a code and see what's wrong, right? So please type in this line, and you should get 55. You can also store a variable by typing like a equals to a number, any number you like, so that this value will be assigned to this variable. You will also see that on the right-hand side, all right? So the left-hand side, the command window is a calculator-like environment. You will also see your bug reports here. If there are some error, if there's some warning, you will see them all here. If you take it lousy, you want to just get rid of all of it, you can use this command called CLC, all right? So after you put in those values, please type in CLC and hit enter. And you'll immediately see that all the values are just vanished, right? On the right-hand side of your window, it is your workspace. So all the variables are here. If you want to get rid of the stored variables, you use this command, clear all, and they'll all be gone, right? So this is all about the command window. Next, please hit this button, new script. When we're doing coding, we don't like to use a calculator-like environment since our program have more than one line of code, right? So you don't want your program to process it as soon as you type in one line of it. So we go into this interface. We call it a script editor, so that you can complete your program and hit run, so that it won't do it will do it as you like it to do. So you should program you should develop your program here. And the second point is that if you want to put a comment, you use a percentage mark. A comment is like a note that tells you what this line does to the code. So if you want to revisit your code, like say 3 months later, you will be able to understand what you were doing previously. If you want to separate your code by like segment number 1, segment number 2, segment number 3, you can use a double percentage sign, like I use here, double percentage, and I write prism, so that this segment is all about prism. I recommend you to all start your program with 3 commands: clear all, close all, and CLC. Like we mentioned previously, clear all simply eliminates all the variables stored, right? Close all simply close all the figures you generate previously. And CLC clears everything on the command window, right? So I always start my program with these 3 commands so that I can guarantee that the running program has nothing to do with the previous program that my Matlab is running. Okay, if you want to run a program, you should hit this button here. We have a run on this point. If you hit it, your program will ask you to store your code. And there are some criteria when you're storing it to prevent bugs from happening. First of all, you don't put spacing in your name. So on the right-hand side, it is a counterexample. Homework 1, there shouldn't be a spacing between HW and 1, right? The second criterion is you shouldn't start your name with a number. So you cannot put 1 homework. This is not allowed. Also, you should prevent your file from putting into a path with Chinese characters. If you have 桌面, don't put it there, all right? Put it in your CDIX, then what you have. So if you violate these 3 criteria, you're going to see this window here. So if you see this window, there's something wrong with your name, right? And now, let's talk about matrix operation. Since we mentioned previously, Matlab is all about matrix. So in this section, we're going to talk about the generation, the operation, and the plotting of matrices, all right? So let's start from the generation. If you want to generate a matrix, you can use this command. A is equal to bracket, okay, bracket, quite important. 1, 2, 3, so you can see all the numbers are separated by commas, right? And then I have a semicolon here. A semicolon simply tells your program to jump a line, or you can say go to a second row. So in row number 1, I have 1, 2, 3. And after that semicolon, I go to a second row. So 4, 5, 6 is here, and 7, 8, 9 is here. And this is how you generate a 2D matrix, right? But sometimes I want just 1D matrix. And there are 2 ways of doing it. So say I have a B matrix. I have B equals to -5, a colon, 0.1, and 5. There are 3 elements in this equation. So let's talk about the first and the last numbers, all right? The first number simply states the initial value. The last number states the terminal value. So you can see on the matrix representation, I start with -5, and I end with 5. The middle number, 0.1 here, means the spacing of each element, right? So this is an arithmetic sequence. It is linearly distributed from -5 to 5, this segment, right? You can also use a different kind of notation. Say C is equal to length space, 0, 100, 1000. So this is a different kind of statement when you want to generate a 1D matrix with linear spacing. The first number is, again, the starting value. The second number, on the other hand, is the ending value. So you can take the right-hand side matrix as a reference. So 100 is where it ends. The last input of this function, 1000, means there are 1000 elements in this matrix, all right? So these two operations simply do the same thing, but they do it differently. If you want to control your spacing, you use this method. If you want to control the number of points, you use this method. Any question? No, okay. Last one, zeros. So D equals zeros, 1, 100. Okay, this is slightly different. Sometimes you want to start your matrix with an empty array with nothing stored inside, no information. So you can use zeros. This basically generates a zero matrix. So every element in your matrix is 0. What is 100 here? 1 means the number of rows you have in your matrix. The second entry, 100, is the number of columns. So this statement here simply says, I want to generate a matrix with all the values be 0, and I want the dimension of this matrix to be 1 by 100. So you see the exact matrix here. Right? That's how you start. Say, if you have a program and you want to modify a matrix, but where should I start from? I can start from all the values being 0. All right. When I have a matrix, I want to call the values out of it so I can make use of it. So say I have a matrix called A, 3, 4, 5, and 6. You can see that is a linear matrix. If I put A parenthesis 3, okay, notify this. This is a parenthesis. It's different from a bracket, right? So bracket is used when you want to generate a matrix. Parenthesis is used when you want to take a value out of it. There's a difference. So A parenthesis 3 simply means I want to take the third value of A. So in this case, it is 5. So let's try this. Go to your command window, right? Command window, not a script editor. Type in the first line, A equal to 3, 4, 5, and 6, and it's semicolon. Please, all of you. And then type A parenthesis of 3. Parenthesis of 3. Put these two lines in your in your command window. So after you put A parenthesis 3, you should see a 5, right? A 5. There's a difference when you have a semicolon at the end of the line and you have no semicolon at the end of the line. If you have a semicolon here, your program will simply store this matrix into this variable A, but without displaying it, all right? But if you don't have a semicolon, it will display on the command window. So if you want to see this value, you can simply just ignore the semicolon at the end of each line. Okay, second one. If I type in A parenthesis end means the last element, right? So you will call the last element of this matrix A. And in this case, it is 6, right? So you see 6. Next, length. Length of A. So length of A will calculate you the length of this matrix. And in this case, since there are 4 elements inside that, you'll get 4. So that's the first part of calling value. Then let's talk about when I have a 2D matrix. So I generated a 2D matrix first. Before you try this, you can type in CLC so that everything is clear. And you type in clear all, right? All right, so I have this matrix here, 3, 4, 5, 6, 7, 8. Now, if I call A parenthesis to 1, since it is now a 2D matrix instead of 1, the first entry is the number of rows, and the second entry is the number of column. So row number 1, row number 2, column number 1, I have the number 6. So you'll see a number 6 like pop out after you're typing this. Also, I can do A1, comma, a colon. A colon in this scenario, in calling various scenario, is for every single element. So I want to call this matrix A, the first row, and everything in the first row. So in this case, it is 3, 4, and 5, right? The first row. So you see these 3 numbers displayed. All right, then let's talk about operations. The arithmetic operations we've learned are addition, subtraction, multiplication, and division, right? So let's start from stating 2 matrix, 1, 2, 3, 4, 5, 6. If I want to add them up, I can simply put A plus B, and I get all the values displayed. If I want to subtract them, I get -3, -3, -3. Okay, what's the next operation? Multiplication, right? But if I do A multiplied by B, I'll get error. Why? Why is it error?
It's all about 1 plus 3.
Right. Right, because the dimension doesn't meet, right? Like we mentioned previously, Matlab is a matrix program. So if you do A times B, you will consider this as matrix multiplication. And as we learned in high school, matrix multiplication is far more complicated than just multiplying things, right? So you should do it this way. A period multiply B, right, with a period in the front. This period stays for element by element operation. So if you do it this way, this program will take the first element of A multiplied by the first element of B. So 1 times 4, we get 4. And it will take the second element of A multiplied by the second element of B. 2 times 5, we get a 10, all right? And 3 times 6, we get 18. Any question? Division works the same. So if you put A period divided by B, then you will take element by element division. Squaring is also the same, right? So this is the operation. So mostly the error will come from the lacking of period in the program, right? Let's talk about the graphs. The reason that we choose Matlab of the tool when we are dealing with the homework of this course is because Matlab is very good at graphing, right? And as we know, a physical formula tells you nothing more than like the form. You don't really understand the meaning of each parameter inside that. But with a graph, you can simplify it to, say, 2 variables or 3 variables, so you can see clearly how each variable affects each other. So let's talk about the first very important command called plot. So if I have this, x equal linspace -10 to 10, 1,000, I basically want to graph y equal to x squared in this program. All right? So I put y equal x squared. That's quite common. Figure 1, so I want to put my figure in this, this name, figure 1, and I put plot xy. Quite simple. Please do this. Put this on your program. And hit run. So when you are programming, when you're having several lines of code, you don't want to put it in your command window. You basically want to put it in your script editor. All right? So open a script. And then put this down, hit run, and your program will ask you to save it. So name it with not violating the naming criteria I just mentioned. Save it and run it. Okay, what do you see? You just see an error, right? You should see an error. And if you go to a command window to inspect that bug, it will say the dimensional matrix is not matched, right? Something like that. Why is that true? Why do we have that? Where should we modify? The second line, right? X squared. So let's think about what x is. I say x is linspace -10 to 10 with 1,000 points. So x, if I put it here, is actually from -10, we got allowed numbers, to 10. How long is it? 1,000, right? So it's a 1 by 1,000 matrix. If you multiply that matrix by itself, since it is not a square matrix, of course, the dimension won't meet, right? So in this case, I actually want to take every element in X and square it, right? So I should use element by element operation, a point in front of square, right? So if you multiply that, you have the correct figure, right? So this is the first thing about plotting. So mostly when you have multiplication, division, or squaring, or raised to the power of 2, basically exponential relations, you have to think about, am I dealing with matrix or dealing with the elements inside that? So this can prevent you from making this kind of mistake. Next, labels. Labels. When we have a graph, labels are very essential since you want to ensure that your audience know what you are talking about, all right? So there are several commands I'm going to introduce. First of all, I have figure 1, and I say plot x1, y1, x2, y2. So in this figure, there are going to be 2 curves. The first curve is described by x1 and y1. The second curve is described by x2 and y2, all right? I'm going to see 2 curves. And then the x label, you can put your description of the horizontal axis here. For the y label, you can put what you want to tell about the vertical axis here. And the title will be displayed on the top of the figure. I'll show you later. And legend, since there are 2 curves in your graph, so legend is quite important. So you put the description of y1, comma, the description of y2, since there are 2 curves. You want to you want your audience to be able to distinguish the first from the second, right? So in your graph, you'll see something like this. This is the X label. So in this case, I have T parenthesis second. On my Y label here, I have intensity something here, right? Intensity W over meter square. And the legend will be displayed here. So you see the purpose of these three elements in the graph. All right? Any question here? No? Okay. And sometimes I have two curves, but their values are tremendously different. Like I have a curve whose unit is like terawatt. I have another curve whose unit is like milliwatt. So they differ by a large amount. So I will use plot YY. Plot YY gives you the two different y-axes. So you can put, so these two curves will not be like, one of the curves won't be like compressed vertically, very dramatically. You can see the details of this command in the slides from Zhang Zhixing, right? Professor Zhang Zhixing, which I offer you in the beginning of this semester. Okay, next, let's do an example. So please launch your program, go into a new script editor. Go into a new script editor. So this is the goal of this example. We want to plot 3 Gaussian pulses whose durations are 25 femtosecond, 10 femtosecond, and 3 femtosecond, right? And if you want to do that, there are 2 relations you need to know. First, what is the function, the mathematical function of a Gaussian pulse? It is like this, right? A of t, this is the complex envelope function, is equal to the maximum of a, which is the square root of your peak power, times this exponential to a negative t over tp squared, where this parameter tp is actually delta t, the numbers, divided by 1.1774. Okay, so let's get started of our program. The first line, like I say, clear all, close all, CLC. So put it down, please. And then I will use 2 percentage signs and write parameter setting. So here I can put in all the parameters like the pulse width or things like that here. So I first need to open up a time window, right? A time window. Because we want to generate a pulse, you first need a horizontal axis. So I use a time window t here. So you see there are 3 inputs. Minus 50 e, negative 15. Okay, this e is for scientific notation, 科学记号, right? So this is minus 50 times 10 to the power of negative 15. And then I have my spacing here, right? Spacing and the terminal value here. And the terminal value here. So use the exact same numbers as I do. We'll explain later. Okay? Next, I have 3 pulses. So I want to specify the delta t's, their pulse width, right? As I mentioned before, we want a 25 femtosecond, 10 femtosecond, and 3 femtosecond. So I put them all in a line. But be careful, I put semicolon in between so that my program will take them as 3 lines instead of just 1. I put in 1 line because these slides, the space is kind of limited. So I don't want the font to be too small so that you cannot read. Okay? After you put this down, then we can calculate the corresponding TPs by taking the delta t's, divide them by 1.1774. Why do I choose these 3 numbers? Let's start from the first number and the last number. They are the starting value and the terminal value, right? Since our pulse are having width of 25, 10, and 3 femtoseconds, which are times 10 to a negative 15. So using 50, like plus minus 50 femtosecond is quite enough to store all my pulses, right? So that's why I choose them, so that I can ensure all my pulses are inside the window. Here, why is the division without period? Why don't I need to put a period in the first place before this divide, like the previous case? Right. So because this is a constant, 这是个常数，常数除常数不是矩阵，所以不需要。如果这个是矩阵呢 ？How about if this is a matrix? Do I need a period? Do I need that? Or don't I need that? Don't, right? If this is a matrix, I also do not need a period. Why? 因为我是拿矩阵除常数，所以不用。 只有矩阵除矩阵要加点 ，OK？ 矩阵除矩阵还要加点。那常数除矩阵呢 ？Okay, let me put it here. Matrix M, I would put M, right? Point divided by M. If you have matrix and matrix, you need a point. Matrix divided by constant. How about constant and matrix? Do I need or don't I need the point? 是的，
把那个常数拉成一个矩阵。
对，你要先把常数做成矩阵。
Right. 如果你不想把它拉成矩阵的话，你要加点。OK? Now try that by yourself.